DevOps is a very important principle, but what really is it and how does it relate to Azure SQL? Learn more in this episode of Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by Arvind, a program manager on the Azure SQL team. Thanks for being with us today, Arvind.
Hey, thanks for having me and thanks for the opportunity.
Yeah, excited to have you. And before we get started, can you tell us just a little bit about what you do?
Sure, I'm part of the Azure SQL program management team or product management team, depending on how you want to put it. I work on a feature within Azure SQL Hyperscale, but one of the other things that I do along the way is look at DevOps and what it means for our customers and users in the context of databases and specifically Azure SQL.
Awesome. Well, it seems like you're the right person to have on the show today because we're going to talk about DevOps. And before we get really into the, meat and potatoes of what we're going to talk about, I just thought it'd be good to do some level setting and talk about, what is DevOps, why is it important, and then how does it relate to Azure SQL? Do you think you could kind of take us through that?
Thanks for the question, Anna. I think the easiest way to understand what DevOps is and what it means in the context of databases, specifically Azure SQL, is to perhaps relate to some anecdotal memories that I have. And I'm sure most of us have heard this phrase, which says, "Oh, it worked on my machine." In very simple terms, I think one of the objectives of DevOps is to ensure predictability, ensure repeatability of operations, and we want to get rid of this phrase. So the idea is no more works on my machine. And just one more anecdote, I think, to give more context. Last year, I was working with a coworker who had posted some code for review, and she had come up to me and said, "Hey, Arvind, can you take a look?" And I said, "I trust you, and I'm going to approve it." And she said, "No, don't do that." And she said, "I trust the pipeline, and once that succeeds, maybe then that's when you can approve." And this is, it may sound trivial, it may sound simple, but it's profound in my opinion, because the word she said, "I trust the pipeline," and that's so important. I think DevOps aims to eliminate a lot of the human element in the development lifecycle, wherein we want to have a machine do things repeatably and with a certain level of guarantee, saying this is going to be a guaranteed outcome. So, in a formal sense, if you look at DevOps in Microsoft's kind of taxonomy of things today, and this is kind of aligning with a lot of what the industry uses today as well, we'd like to break it up into four big phases or four big buckets. There's a planning phase where you set your software project in a structure. This includes things like translating users' requirements to user stories, breaking those down to discrete tasks, then scheduling those into work wherein you have sprints and so on and so forth. So that's the whole software lifecycle process, if you may. And again, you could write a whole book on that. So I'm not going to dig deep into the specific topic, but planning is all about managing your software project, if you may. Then there's develop, where code is created, code is modified, code is verified in a local environment, if you may. And again, this is again a profound thing, because classically many of us tend to treat databases differently. And the whole point of this session is to emphasize that databases are also code. They should be, and they can be treated as code, just like infrastructure as code. We want to have databases as code. We'll show you a couple of demos and dig in a little bit deeper in a minute or two. Then there's deliver, where you look at taking the code that you've written and delivering it into a target environment. In many cases, this could take the form of deploying into a dev test setup, where you're doing continuous integration, continuous kind of testing of your changes. And in certain cases, it would take the form of delivering a change into production, which is your ultimate target for running things. Again, we will take a little bit of a deeper look into deliver in a few minutes. And then there's this final bucket, which is operate. Operate is such a big area where you run the show. So you have your databases, they are deployed, you have users connecting to that through an application. you have a bunch of stuff going on. So performance monitoring, tuning, auditing, there's a gamut of things that come up in the operate bucket. In our talk today, we will predominantly focus on the two most commonly encountered phases from a developer perspective, which is develop and deliver. I think when you look at develop specifically, there's a number of characteristics or aspects that come to mind, some of which are on the slide here. Things like version control, how do you save your code, your database code? How do you collaborate with your peers? How do you have design time safety? This is a very important principle. I'm very fond of talking about this, wherein you build quality into the code at the time you write it, whereas you don't want to have a runtime incident in production revealing a problem with a piece of code that you wrote. And then having a native support for database language, being able to navigate through it with the latest syntax and so on and so forth. We'll see some of these in action when we look at some of the demos that we have for you today. And then there's deliver. I think deliver is, again, a huge space wherein you have to typically think about how you snap into the rest of your organization framework. So even if you're a small, relatively small kind of shop where you're not, where you don't have too many people involved, but in the end, we want to have a process. We want to have repeatability. We want to have automation. The key words here are things like repeatability. As I mentioned earlier, we want to have a machine deliver changes in a way that it's repeatable. You want to have those changes delivered in an idempotent way. And idempotency, if you have not heard this term, is a characteristic that a change, if it has already been delivered or has been affected on the target, doesn't do that twice. So you have an alter table in a database context. You don't do that twice. You just kind of skip that step. So this is a very important characteristic. Again, you'll see that translate to some of the frameworks, some of the tools that we have as a set of options for us. Security, you want to make sure you don't have a connection string. You don't have a password in the clear as part of your code. You want to decouple your code from these otherwise secret configuration type items. And auditability, I think this is so important. When you have a kind of an automation mechanism to deliver this through a machine, if you may, you tend to have an auditability aspect associated with it. Whereas if a developer went in connected using Management Studio, you don't know what they did on the target environment. And hence, I think these are some of the important characteristics that are associated with the deliver bucket.
Thanks, Arvind. This has been really interesting and kind of eye-opening for myself. If I wanted to go learn more and kind of dive deeper into how this relates to Azure SQL, where would be a good place to start?
Sure. Thanks for the question, Anna. We actually have written up a nice introductory blog post on this subject, wherein, and again, I say it nice, but I think hopefully you'll find it nice as well, wherein we try to encompass the lifecycle again. As you can see, this is the same thing, and break this down in detail. So we look at tools, we look at options for methodologies, we look at the process aspects as well, like how's your branching strategy and so on and so forth. So this is a quick kind of a reference. I would say it's a splendid starting point because we do have a lot of branched off links from this blog post where you can go in and deep dive into the subject.
Thanks, Arvind. This seems like a great place to get started, and I'm going to go check this out. We'll make sure to put links to this and the other content in the description. Now, Arvind, when I start approaching this, and I'm thinking about how I'm going to update or change my database, are there some different strategies or different ways of approaching that?
Sure. Thanks. This is a very, very important question that you asked. There are classically two types of ways to do your database development. There's one paradigm which I call, and which I think the industry also fairly well known as a state-based or a desired state-based approach, sometimes referred to as a declarative way of developing databases. We'll take a look at this in the second part of our video series, but at this point in time, I can summarize this approach as being centered around specifying what you want to get as an outcome. The easiest way to understand this is if we take another analogy again of pizza. A lot of us might like pizza. And sometimes if you want to get pizza, you decide to order pizza. You might also want to build your own pizza at home. It depends on your outlook and your interests. But I compare the state-based or the declarative approach as being similar to ordering a pizza. You just call up a number or order online, depending on how you approach these things, and you specify, hey, I want these toppings, I want this size, and hey, in 20-30 minutes, you have pizza delivered to you. You don't specify in this option how to build the pizza. You let the experts kind of do that for you. It does come at some cost. Obviously, you have to wait for some time. You have to pay money for, which is probably going to be sometimes expensive. And sometimes you don't get the choice that you exactly desire, right? You may not have a specific topping, or you may not have a particular pizza base and so on. So state-based approaches are great when it comes to abstracting the how. They allow you to focus on the what, saying, I need to get to this end state. And you figure out how you want to get there. That's the tooling's job, to figure out the how. So that's approach one, which we'll actually review in part 2 of our series. Part 1 today, we're going to look at a very sort of more traditional approach, and an approach which has been around forever, if you may, which is you define the changes needed to get to an end state. You define the how, if you may. In the analogy of pizza, it's you're building your own pizza. You know exactly what you want to do and how to get there. So, there's pros and cons, obviously, of both these approaches. But in this approach, I think the key thing to keep in mind is you control exactly what you control the how as well of getting to the end state. So if you wanted to use particular syntax, if you wanted to have a very specific T-SQL construct used to effect a change, like changing a column from one data type to another using an online option, for example, you can do that with writing T-SQL code. And perhaps developers, who started off back in the day, maybe a decade, 2 decades ago, this was the only way. You would maintain a set of change scripts, numbered or named accordingly, and that's how you migrate your database. You go through each of these scripts one at a time, and thereby you define the how, and you get to an end state. There are pros and cons of both these approaches. I think in the end of the day, it comes down to what works best for you. And also depend on the tooling choices. Like certain approaches may be locked down to certain tools and therefore certain operating systems and so on. So the blog post has a lot more detail in terms of comparing and contrasting both these approaches. But hopefully with these, with the demos that we're going to show you in this part and the next part, you kind of get a good perspective on which one to use.
Thanks, Arvind. I really like your explanation. I especially like the pizza analogy because it's something I can very much understand about, specifying how you want to do it with this migration-based approach. You mentioned a few times that you have some demos. I would love to see how we actually put this into practice with some sort of example.
Sounds good. Let's get hands on keyboard. So for my demo here, I'm going to focus on a very simple kind of example where we have a database. And you probably recall this app. It's a fitness tracking app that I think you had worked upon sometime back. So in this app, we are actually using a change-based approach, which is you have scripts which implement a database one step at a time and take it through a series of changes. So in this, currently I have the baseline state of the environment set up, where we are creating a table, a stored procedure, which is accessing data in the table, and then some sample test data that we want to use for this project. Before I get into showing you how the change is affected, I want to rewind and show you how we are actually delivering these pieces of code into a database. For this, I am using a free open source library called DBUp. Now, DBUp is not a Microsoft library, but it's fairly popular out there. And for the purposes of this demo, I thought it would be an easy way to explain how change-based approach work. Do note that I'm not officially endorsing it or making other statements about this library. I think it's an easy way to understand how these things work. So DBUp is actually a .NET library. So if you're using a .NET program and actually using DBUp to deliver the changes or the scripts in our project to a target database. There's a lot of code in here. I don't want to go through every single line here, but the key things to keep in mind are the fact that DBUp allows you to abstract reading scripts from a file system. So in this line, you see that we say, pick up all the scripts that are in a particular folder. In this case, it's these 3 files here. It also allows you to abstract certain placeholder variables and in your script. So for example, if you noticed, there was a placeholder variable in my script which had a variable for using passwords. I'm not going to hardcode a password in my script, so I have a placeholder variable there. And DBUp allows you to translate environment variables, which can be set up from within, let's say, an operating system console session, or in the context of like a true DevOps experience, as environment variables within a pipeline, and then run and then build kind of the project for deployment. And then it's actually going to run the upgrade. The neat thing about DBUp is it wraps up all the aspects of actually connecting to the database and checking if the script was already executed previously and so on. It does that by using a tracking table. And I'm going to show you very quickly the structure. So this is a database that I already used DBUp to deploy into. And one of the tables you'll see in that database is this schema versions table. And very quickly, you'll see here that you have the 3 scripts that we ran to kind of get the baseline state of the database. What DBUp does is when it's applying changes to a database, it's going to connect to the database, read information from this table, and then figure out that, hey, I don't need to run scripts 1, 2, and 3. So fairly simple but effective mechanism of incrementally applying changes. All right, so I'm going to make to keep things simple, what I did was I staged a change wherein I am adding a temperature column to the training session table, and I have that saved in a branch. So I'm going to do a git checkout branch. So add temp GitHub is the name of the branch. Now, if I go back to the database scripts that I have within the VS Code project here, you'll see I have new scripts here, 4, 5, and 6. Now, I just want to spend a minute and explain. So this is the actual action of modifying the table. And as you can see, in a change-based approach, like in DBUp, we're going to actually specify an alter table in order to add the column. Stored procedure is changed by using a create or alter. So in this case, you could have just done an alter, but I chose to use create or alter as well. And then I have some new test data, which has temperature as well recorded in the temperature column. So the point here is that DBUp is going to pick up all these scripts, and it's going to look at the schema versions table and then just replay the ones that it needs to. So it'll do 4, 5, and 6 in sequence. To see all this come together in reality, let's take a quick look at how this looks on GitHub. Now, just to kind of give context again, I have a private repo on GitHub. This is something which is very useful. If you have not used it, to try out private GitHub repos. They're free to use. We have a pipeline. We have a workflow, as it's called in GitHub Actions, which is actually delivering our changes. So there's a lot of code here again, and I don't want to spend too much time looking at the specifics. But the key things to keep in mind is that pipelines, or GitHub Actions in this case, tend to use this YAML-based syntax, which is a very convenient way of declaratively stating what you want to get done. And this pipeline, or this action workflow, if you may, is just using .NET. It builds the project, and then it runs it. And when it runs it, as you saw in the the C# project, it's going to take a bunch of stuff from environment variables like the connection string, the password, and so on, and execute the SQL scripts that we had in mind. The secrets come from a place within your project. So if you wanted to take a quick look at that, we will show you where that lives. And you can see here that we have secrets in our GitHub repo. These are not exposed. They are transparently available to the pipeline, but no human being can get in there and reverse engineer the secrets. The last thing I want to show you in this demo is the actual outcome of delivering these changes. If you click on the Actions tab within GitHub, you are taken to a set of runs. In this case, they were runs that we have done on a target database. I'm going to show you an initial one where we ran just the base database, where it had the scripts 1, 2, and 3, if you may. And if you look at the logs, there's a lot of detail again. Just for simplicity, I'm going to look at the one which says run. And there's a few things that I want to show you here. You'll notice here it says it's only running 1, 2, and 3, which is cool because that's exactly what we needed to do for getting the database into place. Another thing to keep in mind is that in the logs, you'll never see the raw connection string. This is, again, trivial but important when you're looking at secrets management. You also notice that this was the first deployment, so it actually created the schema versions table and so on and so forth. Let's compare that with an incremental deployment where I did add the temperature column. So here's the temperature column run. I will go back to the logs again just to show you how things look when you incrementally deliver a change. DBUp is smart enough to go into the database and says, oh, we got a journal table. The journal table is the schema versions table. And it's just going to incrementally run the scripts that we need to run. So this takes kind of like a hands-off approach. The developer need not worry about which scripts to run. All that they need to do is to maintain a simple numbering scheme for the scripts. And that's effective enough to ensure that DBUp does the right thing and delivers the changes to the target environment. And all of this, as you saw, reflects into your database. And I think it's a very neat way to get started with CI/CD. If you have not worked with CI/CD at all, just take a look at GitHub Actions if you're not already using it in some other way. The last thing I want to mention is just a kind of a plug. GitHub Actions is extremely rich. There's a lot of stuff that it can do. I barely kind of touched upon the tip of the iceberg, probably. I do want to also call out that we have a native SQL action, which allows you to take, like, for example, a bunch of scripts or even a DAC pack, which is like a thing that we will introduce to you later. But you can deliver this through a native action for Azure SQL. So there's a lot of capabilities that we have out there for GitHub Actions, which allow you to implement DevOps for Azure SQL.
Thanks, Arvind. This has been really useful. I mean, you've really covered a lot. I'm going to have to go do some additional reading, and we'll make sure we have all those links in the descriptions for people to learn more. As we kind of close out, I was thinking about the Azure SQL family, and, could I use this same set of principles with, say, SQL Server on an Azure virtual machine?
We could. And the good thing with DBUp, as an example, again, because it's just one of many frameworks, there's other similar frameworks out there. Most of these change-based frameworks tend to take a connection string. And as long as we have right credentials, as you saw in the secrets, we have credentials out there. As long as you have that in place, as long as you have network connectivity to the target endpoint, which is, let's say in Azure, it's a network security group or something of that sort, it'll work just fine on a VM as well. So yeah, it'll work. That's the short and sweet answer, if you may.
Awesome. Cool. Well, thanks so much for coming on the show today, Arvind. In our next episode, we'll take a look at a slightly different approach. So we hope you tune into the next episode. In the meantime, if you like this video, please like our video and leave us a comment and let us know what you think about DevOps and Azure SQL. We hope to see you next time on Data Exposed.